that's a different team, so you can go somewhere
What
else.
number is it at? It's the number, sorry, tell me the group number.
You don't look like from Chile.
Sorry? Yeah, no, sorry, this is,
Yeah.
We don't look
you're
like.
at,
Actually, I think there are lots of immigrants in Singapore. So
Good answer.
you're right.
I think we gotta wait like a minute or something.
Sorry, let me just check the official time. We've got 1 minute.
Alright.
We got 1 minute.
Maybe he'll
My
running.
bag.
Maybe we should dip your back.
Yeah.
Where would you guys like this?
Close.
Close?
Get closer so we can see it. Bunch over. There it is.
Stairs down. To the left. Stairs down.
I think we could switch it off.
Let's turn that one off.
If you could
TV off?
switch this off. Because
Yeah, do it.
do it. Because
it still makes sound.
I told you not to do that.
That's a sound.
Thank you.
Ready?
Yeah,
Yep, we're ready.
Ready? All right, start.
Hello again. To start with, I feel we didn't verify some answers at the questions. So for our presentations, we want to make that all clear. So to start with, about the learning by playing part, well, we adopted the approach of MindLab. MindLab is an innovative in-school methodology for developing children's thinking skills. It is adopted in 25 countries and 10,000 students use it, even more teachers, and it's proved to work for the children. This method works for them to develop their thinking skills. So this is what we wanted to do, to make them play and learn at the same time. And about the multiplication game we had in our demos, if you remember it, the teacher actually suggested to make it a bit more competitive. For example, the teacher can say, I will reward the person who makes the most right answers in 1 minute. So the children will be engaged to think faster, learn faster. It's not just turning the cube and matching randomly the answer. I will let my colleague tell you.
Yes. Another thing we feel we didn't clarify is the fact that we have a software platform that is expandable. Basically, we can add more hardware. We can add other phones with Android. We can add tablets. We can add even iPads, Kinect, whatever has a purpose. So yes, it's not just cubes and the Windows Phone. Also, we are selling the cubes as a kit with 6 cubes, and we also have a single board computer here. This is how the cubes communicate with the internet. It coordinates them, and it also caches the experiments, so there won't be a lot of traffic just until it's downloaded.
Why we push this forward is because we need that initial investment to make our
Yes.
solution grow. So we thought that with these kits, which are innovative and interactive, we can make that money faster and then develop our solution to more customers and more devices.
Right.
we'll just have to start the cubes.
Besides, these are the new cases. We designed it. We have feedback from the kindergarten, and they told us the edges are too sharp there. And we also get some holes to hear the sound better. And this is the new design for the cases. It's done with a 3D printer.
So, we have here,
Let's on the table.
you can come closer.
You can come closer to see the.
So, if you associate the cubes, it will turn green.
On the top.
Times
On the
four.
top.
The side that matters is the top. They contain accelerators. Round. Okay, and each of its sides are detecting, and you can even place them on top. So it's expandable in every direction. You can create molecular structure with this. So this is just a demo. Correct. And now my colleague will show you how these experiments can be customized using the cloud.
This is our editor. We just select a cube game, and we just have to drag the pictures on each side. Specify that this is the start of for a cube. Give it a name. Wait for the other cube as well. And what's nice, you can actually preview a 3D cube here to see how it should be. Right. Save it. Give it a name. You can here specify a fun factor and a science factor, but we're not going to use it. And for now, we're not using the single board computer due to the development time constraints, so we're using something connected to the PC, but that will change. That's the priority now, to make the kit, the whole kit. The experiment is here. You see that on this cube we have the pictures that we put there with objects, and on this we have some new numbers that weren't there before. And what's nice is that the experiment still works. So 9 times 6 is not 6, but it's 2 times 3. Huh?
Choose another. Just choose another
It was this side, but we recently broke the cable. Yeah. Yes. So it's really easy to configure it, and it's intuitive. It's drag and drop.
Okay, this is just a simple demo of
Yes.
capabilities.
Yes.
And it can be expanded to
I want to show you now the marketplace. First, the teacher or whoever is using the marketplace can choose the education level using this slider. And why we let all these education levels? Well, for us, the software and the hardware is the same, whether it is for primary education or the secondary education, and we didn't want to limit our solution to the primary education. a selection would be made in time. If we see on this marketplace that there are no experiments up to the secondary education or no downloads, we will see that it's not feasible, and therefore we will retarget our audience to just the smaller children. But for now, we are testing our solution and testing our market. Let's take math. Here we have a list of experiments for the math section from primary education. This line number here helps us select the science factor because we want to let the teacher choose how much science or how much fun the experiment will be. And as you increase the fun factor, it means you want it to be easier and more fun than scientific. And the experiment is more depending on their fun factor. They all have this specification. So, the basic multiplication, that was all. For each experiment, we have the education level, the subject, the language, and the author, the prize, the author, and if there is a prize, maybe we want to set it for free. The science factor, the description of the experiment, the technology it's using. It might be the iCubes or a phone or whatever. And we also have the number of downloads. And after your questions today at the presentation, we also thought it would be good to add a score so that anyone who wants to download the experiment can know from the other users if it was useful, if it's correct. This is also an element which makes the difference.
Rating and comments.
And also we have the reviews, yeah, and we can see from the reviews that people can see if it's worth it or what to change to grow this platform. And also, after today's presentation, we added the type of experiment category. We realized that our experiments are somewhere between simulation and real life experiments, so I think it should be clear for the people who are downloading the experiment what type of thing it is. Like when using the phone to calculate the speed or the acceleration, that's quite real life. So, and you should know that. If you do a chemistry experiment, it would obviously be a simulation. When we push get the experiment, it will communicate with the teacher's interface, and the teacher will be able to schedule the experiment and prepare it for the class. So that's really one. So if you would like to see the cubes and check out with
So are you done presenting?
yeah.
Okay, because we were told not to interrupt you and then
Yeah.
we
Yeah.
so we can now.
No, yeah.
Can you open one and show me what's inside?
Sure.
I'm interested in the storage and the screens. Can I only show pictures or can
No.
you show other things?
Movies as well.
What about like LED letters and numbers without
You have
pictures?
the. We have a picture.
It's handmade.
Yeah, that's the tricky part.
Yeah, it looks cool.
You can keep one, take it
Okay.
in your hand, and I'll take another one so you can see.
What are those screens? Are mini?
Okay, they are 1.6 inch LCD screens, 65K colors. The storage is an SD card. We also use RAM memory, random access memory. For the speakers, they also can play
Are there
sound.
any position sensor?
Yes, we detect the cubes using Hall sensors. We have ring magnets, and inside we have a Hall sensor. And when we get close to cubes, the Hall outputs change.
No, I'm not talking about proximity sensor. I'm
Ah,
talking about
Position.
where position.
Position. Yes, we have 3-axis accelerometer.
So you can recognize that
Yes,
your
yes, yes.
position?
Yes, this is how the game knows what solution it is.
And has some processor also inside.
It has a 30 megahertz microprocessor.
And how did you download things from the computer
Okay,
to the
we
cube?
have a wireless communication module, X3, and we have this
For now.
for now.
Yep.
It will be a stick.
All right, and the SD card.
The SD card is here.
Okay, and what is that exactly? What is that?
That
That
is
is,
wireless communication module.
Oh, okay.
With
just-
the
we're
COM
downloading the
serial
pictures.
from the computer.
So do you guys record how many times they get like a correct answer versus an incorrect answer?
Yes,
Yes.
and we can use this data to even determine some diseases like ADHD and process these data. So my colleague. will
yes,
tell you.
and
It-
also we can score the children, and if we have enough of those kids out there, we can do business intelligence. Since let's say we had 300,000 kids, we have a relevant data saying how many children scored good in school compared in a region compared to another region. So we actually are thinking about using Power Pivot for that. You can just connect directly to the SQL database in Azure, download the new and relevant data, and generate a report on that.
I have from your presentation during the last time, I was curious about the topology of that. For example, here, if you want to add, for example, here, you can have it. You can have that way.
Yes,
But
yes.
once you go up,
Yes.
I was wondering that the user can see only front or behind.
Yes, yes, yes.
How do you decide the user see that which
Which one?
face?
For
That
now-
is very important
yes,
point,
yes,
but you
yes.
didn't mention at all.
Yes. For now, the face that matters is the face on top.
Ah.
So the accelerometer
So
determines which
if you
face
look
is on
at
top.
this, this
No,
doesn't make
no.
sense.
Yes, it does, because you make it relative to the face on top.
We can change that. We can change
But
which side matters.
How you can choose that? How you can choose that?
Through the software platform, from the workflow.
No. You are teacher, I am the user.
Yes.
I'm young children. I'm supposed to start this one, and I have to look at this side or that side.
You know in advance. The teacher tells you the size that matters is the size on top, and it can change.
Because once you add this way and that way, it's a totally different thing.
Yes.
In topological. Yes. But in the demonstration in your video,
We didn't
you said that one is the same. It is not the same.
Yes, it's not the same.
Yeah,
And
exactly.
the cubes know which face have
Yeah,
been
exactly.
connected.
That has
And
to be
this
decided.
can be changed.
Yeah.
Very
Otherwise,
easily. Yes.
totally different combination can.
And this is 3D model of the cube and what's
I mean,
inside.
that will be more complex if you use the 3 cube.
Yes, yes, yes.
Actually, this is a good idea for the future
Yes.
to let the teacher choose which of the faces to use and how many of the faces.
And actually, you can build a game on top vertically as well.
Yeah, yeah.
Have you got one
Space
hooked up with
Yeah.
3? Have you got one hooked up so that you can join like 3, like 7 by 6 by?
Yeah, I want to see
For
also.
example, for
Any
now, no.
operator
For now, no.
no,
Yeah.
Have you guys done any? Have you got any games that use two that share video?
Yeah, sorry.
Are there any that share video instead of still images?
No, we only have recorded.
Okay.
Do you have some experiments already in physics to show in iCubes?
Well,
No,
we
for
have
phone.
For physical habits.
For Windows Phone.
That's my question. So, for example, sorry, but is your project about iCubes or about marketplace?
About all of them.
No,
It's
the
about
main
the
software
aspect
platform.
is the software platform and its extensibility. And one of its extendable components are custom-made iCubes. So
So
the
you-
idea is the software platform is
So
the
your
main
decision
part.
is software
Yes.
and not hardware
This
plus
is,
software.
This is to make
optional.
this is to make profit in the first year to help us sustain.
Because it's hard to understand. You named your project iCube.
No,
That's the team
That's the team. The project is this.
DiveX Live platform.
So the icons is one custom. You can attached to the software platform, also iPad, Android.
I'm interested. If they have a Wi-Fi module, is there a reason why things cannot change in real time? Like a teacher pushing things in real time and changing the game while the kids are playing?
Yes, we all know Wi-Fi is not quite real time, and there are some
Real
time. Yes, there are some.
It's not Wi-Fi. It's Zigbee. It's a low power protocol that's also low speed, but we need low power because
it's
other.
Zigbee.
Yes.
Okay.
So can we actually, you can have a 6 times 5, which is too easy. And then we want to make a little bit.
Yes,
and you can
yes.
change it dynamically.
Yes.
Oh, well, that was my
actually,
question.
we did that. We did that just now. We changed the numbers on this cube.
How?
Show it.
By putting in the
Yes,
data.
we actually yes.
Everything
created the,
Hold on the cube, yeah.
I will hold it so there's no magic there. You push a button and then
I created this new cube with
Okay.
just numbers, right? Then I submitted the experiment to the cloud. Now through the coordinator, just configure it, and if you're close enough, it should start.
all right.
Oh, it works. Yeah.
So is this polling or that pushes?
We have a predefined protocol.
Yes.
The coordinator does the work. He decides. Now, cube 1, now you listen. I will send the way.
How do you know which cube's which?
Raymond, what is the way?
They have a predefined hard-coded number based on, yes, the Mac.
Yeah, but when I want to update this one, how do I know which one to push it to rather than updating that one?
in an experiment, you choose the cubes based on a number from 1 to n, and then you just keep using the same number. And
And we have, we have certain commands that let you identify the cube. You send identify cubes, and all the cubes receive this command, and one shows in green, one shows in red, one shows in red.
And also we got this idea from the kids from the second grade. They wanted to make it even more difficult. So they said we could change the products on what is this every 30 seconds, so it would be more challenging. Find really fast. It's basically anything you can imagine to do.
Okay, so you basically using the cube, you want to experiment with
mathematics, music,
Chemistry.
How about biology? Biology, not
Yes, like determining donation compatibility
yeah, that's something.
or eye color.
Yes.
Yeah, no, the parents have this idea.
What about trying to compose an image of the circulatory system?
Yes,
Yes,
Like
that's
a wall.
good. Yes, that can be done, but
Molecular structure
Yes.
of some elements. And also a big advantage, because they are 3D, they are not just 2D cubes, we can also generate a 3D image through the 3 screens. So when you can see the 3D image inside.
Actually, relate to your question. This cube has more potential of display.
Yes, it also has a commercial potential.
yes,
And that's what we're counting on when we're
yes, we need money to sustain us through the first years.
That can get your money.
Yes,
That's
plus
why we're pushing
rather
them
than
forward.
this.
yes.
Because the poor country, I don't think they could afford such a luxury toy. Very much.
Like actually, the hardware inside is pretty cheap. The microcontroller is low power because we don't need that much processing power. Everything is done via cloud, so we can keep the cost reduced. Plus, even when talking about low cost, ARM released new 32-bit M0 Plus for 50 cents. So
If you want to stay on the market,
Also the judges from the first round gave us some factories from Hong Kong. They told us this is the factory that makes this component really cheap. This is the factory that makes this component very cheap. And they told us it's really nice, you can get it very cheap.
So
all this.
So we're going shopping after.
Would you be able to demo the Windows Phone physics one?
Sure.
sliding.
Yeah.
Yeah, the slide was on
Yeah.
an angle like that, but the one they showed was more like that.
Let's see the sign right here.
this? Yeah.
Report?
Yeah, on an angle.
It's-
Yeah.
Yeah, it starts with a description of the theory of the experiment, then methodology, and it says how to use this experiment. So it says it on a plane, here, and just can you
Catch a phone.
Yes, catch your phone, please. It's a brand new. You don't want to break it.
I know this was
Oh.
yeah, we had it before.
and it was a little bit blurry. And then you press the point, and it shows in each point the speed and acceleration. And the students, for example, can check the laws of physics if they are.
They get the data, and
Yeah.
it's real data. It's exactly
So
what the
if
phone
you would
recorded.
do this in a normal laboratory, you need very expensive equipment to measure real time and the graph of the motion. And
That's another.
another, the centrifugal force. This is about the centrifugal force. For example, if you have a glass of water and you spin it fast enough, it won't spill. So here's the glass of water. If you do this, it will spill. And I'll try to do it faster. And it stays. And also, we have this like breakdown. We're using the light sensor of the phone to see if we find enough light. The camera moving.
The phone is
The camera phone.
prism.
And if it finds light, enough light, it will show the.
Each one of those is custom built, or you have a framework to build experiments?
We are doing it through the workflow editor, but we also need a scripting language for Windows Phone because it has certain limitations. And for that we're using Iron Ruby, and we're working on auto-generating those scripts.
And that workflow generator is that Windows Workflow Foundation?
Yes, Windows Workflow Foundation with custom activities. So we have such an activity for
And
example.
when you download things to the Cube, you also download the logic, right?
No,
Of the
we
game.
will cache it. We'll cache it here at most on the coordinate because we can't run .NET
The
here.
cube is just an interface. It just sends its state, its
Oh.
current connections.
Okay,
its
so
current
so the
orientation.
green or red is not decided by the Cube.
No,
Decided by the
That,
cloud.
this makes them more low cost,
Yes.
replaceable.
You don't have to reprogram the
And
cubes.
what is the range of how close they have to be?
The cubes?
The cubes to the kit.
To transmit.
Yeah, to transmit.
1 to 2 meters for now, for this.
Yes, we
device,
have
for this
no
experiment.
other actually on this one.
Yeah, because in a classroom, well,
Yeah, we
1 or 2 meters.
yes
is-
we well Zigbee goes up to 50 meters.
Okay.
Here is also the problem to find the best modules because a lot of companies make CFPs and some are better than others.
Okay. How many color you have as the signal? Only
RGB LED, so
red and green.
Red, green, blue, and you can form any color.
yeah, it's
the
PV.
moment.
It's
At the moment, 7.
Seven.
We only combine the colors. This is for demonstration.
So green is the you got the answer.
And there's an animation. It shows that it can display
That
animations.
when it's placed on its charging.
Can it vibrate? Does it vibrate?
Yes.
Yes,
Vibrate.
you can feel it
Sound?
with the- Yeah, sound. Also sound.
And here is the charging. It's still a point. If you put it
Using
in,
We'll
inductive.
show
Oh,
the.
cool.
we made it in the laboratory and it worked. We got
We
a
got a 55% efficiency.
without special effort.
Without special effort. So this is not that good. Currently, it's modern scientists came up with 96-95% efficiency.
Otherwise, you have
Wireless
to
and
open it
electric.
and then replace the battery.
Yeah, no, we have an access port for the power, but that's not user friendly, so we're going with inductive charges for the
Who's been making them all, sticking them all together? Have you been sticking them all together? Like you've been putting all the bits in? Or you been?
Yes,
These
yes.
are-
They are all custom made.
Yeah.
Lots of time involved in it.
Handmade. It's
Yeah.
really appreciated these days.
we designed it to be very portable. So the teacher gets its cube, it gets it and he goes from the school to school. Really,
Close the.
yeah, everything, and you can transport it anywhere. Put it in the sun. We have batteries. It gets charged.
Okay, you guys very scientists.
Maybe to understand how.
What do you guys study?
Change.
What do you study? All computer engineering?
Yeah.
Computer science, actually.
So no electrical engineering?
Actually, at our school we do both hardware and software.
Oh, okay.
When you say engineering, my school is also concept engineering. Therefore, the teacher is we learn electronics.
Yes.
Well, good job, guys.
Yeah, congratulations. Thank you very much.
All right. Thanks again.
Thanks.
Thank you.
Good luck.
Thanks.
All right.
Thank you.
Congratulations.
How it went?
There you go.
Guys, so these are my colleagues from Microsoft.
Hello.
I'm Sebastian.
Victor
Hi,
Andalian.
nice to meet you. Hi. There you go. Hi.
I'm delighted.
So I didn't get a chance to see those cubes.
And we would like to ask you to give us a personal presentation.
Private tour.
Exactly. Exactly.
Yeah, they will. No. Yeah, we set this one.
A short demo will be more than enough.
Yeah, but we just changed for the joke, so we have
We changed, we have updated the slide.
You updated the picture on the side?
Yeah, we showed how the teacher changed.
So, Sergey, what did you think about all the pictures just from Azure to the Cube?
Yes, from Azure, they are first downloaded to our coordinator because we don't have